There's a strategy in programming called recursion. And if you become a hardcore computer scientist, and by I mean go to grad school, work on a PhD, um, recursion might become a very big topic for you. If you don't, you might not use recursion all that often. I worked for 20 some years, and I can't ever really remember an application that was only solvable by recursion. Not to say that there aren't some, but recursion is a problem-solving strategy that's really great to take complex problems and give them very elegant, simple solutions, but not necessarily an intuitive way to attack it once you've learned other ways of programming things. So as we are going into recursion, I want you to be aware of the fact that it's often considered to be a very complex subject. It's very difficult to teach, very difficult to learn. And I think that that's partially because we try it the wrong way. We teach it the wrong way. We teach it as in a subject, like if I tell you the rules, you'll figure it out. And so I'm going to tell you in this video what recursion is, what's about, what's the rules, what the conventional wisdom of it is. But beyond that, we're going to really just practice a lot. Just get a lot of experience. It's kind of like riddling. Yes, if you're a logical thinker, you can solve riddles sometimes. But the best riddle solvers are probably people who've just read a lot of riddles, that they're just more familiar, that you have the habits of mind and the patterns that you're used to seeing of how riddles are written. And I believe that's true of a lot of recursion as well. So let me give you an example of a recursive algorithm. And I know not everybody, if you might recognize this right away. If you don't, it's a picture from Minecraft, and so you don't have to be in the Minecraft to understand this. But if you do know Minecraft at all, this should hopefully make you understand it pretty well. So this is what's called a Nether portal in Minecraft, and it takes you from the regular Minecraft world into the Nether world. And it's fairly simple, to get a Nether portal. This is made from a material that they call obsidian in the game. Um, and so you need to have a specific tool in order to mine your obsidian. So if you want to make one of these, you need these little blocks of obsidian, and then you actually light a fire and it opens up. Um, but to get that, you first have to get yourself a diamond pickaxe. And so to get obsidian, you first have to find diamond. And then you can make a diamond pickaxe using wood, which is really easy to get in diamond. But in order to get diamond, you have to mine that by using a iron pickaxe. And so it's the same process here. So in order to build the nether portal, I have to build a diamond pickaxe. In order to build a diamond pickaxe, I have to build an iron pickaxe. But in order to get iron, I need, most likely, the easiest way to do that is to go get a stone pickaxe. And there's also a wood pickaxe inside of there. And sometimes I start with a wood pickaxe as well. And so the process of getting this, you can see immediately has a certain amount of recursion to it. In order to build a diamond pickaxe, I need the the iron. In order to build the iron pickaxe, I need the stone. In order to get the stone, I can use the wood. And so the pattern is the same. What I'm doing is the same. Just one tiny little thing shifts each time, the input material. So if I wanted to use a recursive way of describing this process, um, this is kind of like the algorithm I can talk about. I want to create a tool, and so if I have the material, then I build the tool. Otherwise, the process is I need to go get the material I need the tool, then build that tool, um, and then you'll build the next one. But if I need some other tool, then I have to go first build that tool. So in the process, as we said, if I want to create this tool, the nether portal, then I start with in order to make a nether portal, I need to get obsidian. In order to get obsidian, I need a diamond pickaxe. So I have to create the tool diamond pickaxe. All right. So in order to get a diamond pickaxe, I need the iron and iron pickaxe. And so I need to go get iron for that. And so I need to go find that. But in order to mine the iron, I need to get a stone pickaxe. And so I can start off, I can gather that by hand. And so go off and find the stone, and then I build a stone pickaxe. But then at that point, I can go off and get the iron, iron pickaxe, and then at that point, once I have the iron pickaxe, I can go find the diamond and then mine it, build the diamond impacts, the pickaxe, and then I can go find the onyx and build that. So this structure, this recursive structure, actually fits into one of the data structures we're going to be talking about as well, the idea of a stack. So it's kind of like, hey, I want to go read this book um, in Latin. Well, in order to do that, I have to go first learn Latin. Well, but then I get a book about Latin and I start reading about Latin, but then I find out that in order to be able to read Latin, I need to go back and read Aramaic, and then before that, and so on and so forth. So it's the same process stacked up. If you remember, we talked about the stack in a previous lecture. And so the recursion and the stack have a lot in common. We won't actually mess with the stack data structure at this point, but inside the computer, that's what we use. We stack one process above the other in order to make that happen. So logically speaking, the rules of recursion is, if I need to engage in a task like firing iron, um, I don't necessarily know that that task has a higher purpose. When if I'm playing the game, I'm running around finding iron and looking at iron. I'm not thinking about the fact, well, I need iron in order to find diamond, and I need diamond in order to find obsidian. I need obsidian in order to go to the netherworld. And I mean, at this point, if you've played the newest update, there's a new material in the netherworld which you can make even better stuff than diamond stuff. So that the recursion gets bigger, if you will. And a lot of video games are built on this idea of recursively completing similar tasks in order to get better stuff. And what's different about the stuff? Oh, it's the same stuff. It just has better stats, if you will. But yeah, that's the fun of video games for those of you who play. Um, so unlike other aspects of programming where we have a contextual awareness of other variables that are around or other things I can call or other states of the program, the idea is I'm supposed to just put on blinders and say my role is doing this thing and the only information I have is the parameters in which I was passed. You gave me some parameters, go find iron, I go find iron. And the task of finding iron, I realize I need to do something else, I do that. And that's a little bit the idea, but it's important to determine what's called the base case. The base case is when I have everything I need to do and I can just find an answer. So again, if I say I need to find obsidian and then I go get diamond, I need to find diamond, I need to get iron, and iron I need to get stone, and stone I need to get wood, wood I need to get, I could go on forever. Dirt, I need to get atoms, atoms, I need to get quarks, quarks. I mean, it gets ridiculous. So there has to be some base case that you can do to start. In Minecraft, you start level 1, you can, with your bare hands, knock down wood or even stone if you want to take your time at it. But beyond that, I need the tools in order to be able to get the appropriate material. And the same thing is going to be true here. So our recursion needs to, at some point, converge down to a base case. If in designing the game, in order to be able to get diamond, I need iron. In order to be able to get iron, I need stone. In order to be able to get stone, I need obsidian. Well, then I have a circle, and I can never actually break into that circle unless somebody hands me one of those existing materials. So I need to make sure whatever my rules are going to be, it does diverge down, result down, simplify down, break down, decompose down into a base case. And along the way, I need to make sure the inputs are valid, or at least plan for the valid inputs. Again, that's easy. Hey, recursion, find a base case, make the problem. But doing that's a little bit more difficult. Clearly, I don't think that most of you probably feel like, oh yeah, I totally understand that now. I totally can go off and do that. Let's go. So what we're going to do is we're going to go through a lot of different examples. We're going to start with this easy one right now, factorial. And so when we talked about factorial, you probably remember from your math class that factorial is, as it says here, 4 factorial is 4 times 3 times 2 times 1. So when I pass in a value of 4, then I know I need to do 3 times 2 times 1. So if I say factorial of 4, then the easiest thing to do is I can say this is 4 times the factorial of 3. And then here I can have that is equal to 3 times the factorial of 2. All right, and then 2 times the factorial of 1. I'm going to get down to 1. Well, I can just return 1. My base case in this case is 1. And furthermore, factorial of 0 is also 1. And negative numbers, we're just going to ignore. There's some mathematical stuff around that. It's too much for us to understand. So what we can actually say is we can have a base case of 1, or we can say anything less than 2, which covers 0, 1, and all negative numbers. So we can say if you give me factorial of anything less than 2, the answer is 1. So and again, it doesn't totally jive, but factorial of -7 will just return 1. And by the way, that might be acceptable. If a negative number is an invalid input anyway, then we can just pretend like you passed in something useful and the answer is 1. The answer of 1 might be better than an error case in this case. So the base case is 1, and then I resolve the base case, and then I'm also handling the negative numbers because they're invalid. So I can either, as I said, get a 1 or just return an error. If for some reason you hand a negative number, I just don't allow it, or I return an error right away. I check that right away. So that's going to be the way of breaking it down. Now doing it in code, pretty straightforward. Factorial of start. If it's less than 2, as I said, return a 1. Otherwise, I do the starting point times the factorial of start minus 1. So I could have solved factorial with a loop. I could have said 4 int I is equal to 4, I is less than I is greater than 1, temporary value is temporary value times I, something along those lines. So we can do those things through iteratively, through the traditional ways of loops and decisions and whatnot. But the cool thing about this is how simple it is. And we're going to see some examples where when I do it recursively, it's ridiculously simple if you can determine the base case appropriately. All right, so I'm going to leave it from there. As I said, we're going to work through a number of examples. I'm not going to work through every example in a video. I'm not going to tell you how to do all of them. I'm going to give you a couple of examples so you get a feel for it. And then you're going to have some homework problems, and you're going to work on those and submit those, and we'll talk about those. And you may not get them right the first time. You might need to talk about it in class. I might need to come out and do some more videos of them later on, particularly if you don't understand how it works, how it revolves to a base case. But this is not going to be a case where I'm going to handhold you through each and every idea of recursion. I believe the best way to learn it, as I said to start this, is just lots of practice, just seeing lots of examples. And that's what we're going to do. That's what we're going to give you a try. And then we'll add videos, we'll add explanations, we'll add stuff as we go. But for now, just know this is going to be a case where we put our nose to the grindstone, so to speak. We're going to put in the work and do a lot of practice, and hopefully they start to get easier to spot the base cases and you see the patterns. I don't believe that all of this is about intelligence and just smarts. And if you're smart enough, you'll find these sorts of things. I do think there's an element of intuition and just some practice that will get you there as well. So let's go.